Next one, example. The self-inductance of solenoid that has a cross-sectional area of 1 centimeter square, a length of 0.10 meter and 1000 turns of wire. To calculate the self-inductance of solenoid. So first of all, take data. This data, self-inductance of solenoid cross-sectional area. A is equal to 1 centimeter square, which is equal to 1 into 10 power minus 2 whole square. Centimeter means 10 power minus 2 meter whole square, which is equal to 1 into 10 power minus 4 meter square. This is area. And length of L is equal to 0.1 meter. And turns, total number of turns N is equal to 1000 turns of the wire. I want to calculate the self-inductance L. What is L formula? L is equal to mu naught N square AL. Mu naught N square AL. This is a basic formula of self-inductance of solenoid. You know well. So L is equal to mu naught. Mu naught is means a core, air core medium. So that's why mu naught into N is a number of turns per unit volume. But we have total number of turns. So total number of turns N is equal to small n into total length. Number of turns per unit length into total length. So caps n. So I want to calculate the small n is equal to caps n divided by L. So substitute the value caps n. Small n is equal to caps n divided by L. So n divided by L whole square into area into length. So L is equal to mu naught into N square divided by L square into A into L. So L square cancel. Remaining value L is equal to mu naught N square into area whole divided by L. This is a formula. So substitute the values. L is equal to mu naught. You know well mu naught value is 4 pi into 10 power minus 7. 4 pi into 10 power minus 7 into 4 pi into 10 power minus 7 Henry per meter. N is a number of turns. What is the N value? 1000. So 1000 into whole square into area. What is area? 1 into 10 power minus 4. 1 into 10 power minus 4 divided by length. What is length? 0.10 meter. 0.10 meter. So L is equal to, substitute the value 4 into pi value 3.14 into 10 power minus 7 into 1000 whole square. 10 power 3 whole square. So 10 power 6 into 1 into 10 power minus 4 whole divided by 0.10. So 10 into 10 power minus 2 in our convenient. Just will be cancelled in easy way. So L is equal to, this is 4 into 3.14, 314 into 4. What is the value? 16, remaining 1. So 4, 1, 5, 4 there is a 12, 1, 2, 5, 6. So 3.14, 2 digits, so 12.56. 12.56 into, this is 10 power minus 7, 10 power plus 6, 10 power minus 4. So 10 power minus 7, 10 power plus 6, you get 10 power minus 1. So this is 10 power minus 4, so 10 power minus 5 into, here 10 into 10 power minus 2, you get 10 power minus 1 to go. 10 power minus 1 goes to denominator to numerator. So 10 power plus 1. So 10 power minus 1 goes to plus 1. So L is equal to 12.56 into 10 power minus 4 Henry. Minus 4 Henry, or L is equal to, this is 12.56 into 10 power minus 1 into 10 power minus 3 Henry in our convenient. So option is also, different options are also available. That's why I want to take the dividend this value. So 12.56 into 10 power minus 1, 1.256 into 10 power minus 3 called as a milli Henry. So this is the final answer. So 1.256 milli Henry is the final answer. Next, in an inductor of self-inductance, L is equal to 2 millihenry. Current changes with the time according to relation I equal to T square into e power minus t. I is equal to T square into e power minus t. The relation between current and time. Current changes with the time according to the relation I equal to T square e power minus t. At what time EMF is 0? At what time EMF is 0? Where time it is I want to calculate time when EMF is 0. The relation between current and time is I equal to T square into e power minus t. First of all, you take data. First one, what is L value? L is equal to 2 millihenry. This is equal to 2 into 10 power minus 3 henry. 10 power minus 3 henry. And next one, what is the relation between current and time? I is equal to T square e power minus t. T square e power minus t. I want to calculate this with respect to time di divided by dt. Differentiate. First of all, you take t square. You know well t square and differentiate with e power t. E power t is a differentiate also to get e power minus t, and e power minus t is a differentiate with respect to time dt. This is minus t differentiate with the dt is equal to minus 1. And next one plus e power minus t is constant. Sorry, e power minus t just will stay in UV method. You know well. First of all, t square is a take after differentiate e power minus t. Another one e power minus t shed e power minus t, and t square is a differentiate with respect to dt. So e power minus t is stable and t square with respect to dt is 2t. So I want this di divided by dt is equal to minus 1. So t square e power minus t 2t. So common factor is e power minus t and 1t. Just I want to take e power minus t and t is a constant, common factor, and this is e power minus t. Here t, this is minus t, minus 1. So that's why I want to take minus. So t into minus 1 minus t, and this is plus e power t, and t is a common factor, comes from the outside from this equation. So get e power minus t and t get 2. So di divided by dt is equal to this equation. I want to calculate this at what time EMF is 0. EMF is 0. What is the formula of EMF? EMF is equal to, you know well, is equal to L into di divided by dt. L into di divided by dt. So EMF 0. So E is equal to, what is L value? 2 into 10 power minus 3 into di divided by dt. Di by dt is e power minus t into t of minus t plus 2. This is di by dt. What is the question? At what time EMF is 0? Just I consider EMF is 0 means EMF is 0, which means E is equal to 0. This symbol E is equal to 0. So this factor total is equal to 0. So 0 is equal to 2 into 10 power minus 3 into e power minus t into t of minus t plus 2. So this factor is divided by 0 divided by this factor 0. So e power minus t divided by this 0. Finally minus t plus 2 is equal to 0. So minus t plus 2 is equal to 0. I want to calculate this. Minus t is equal to minus 2. So t is equal to 2 seconds. This is a EMF, and t is equal to 2 seconds. The time of EMF at the time of EMF is 0. And next one, two solenoids of equal number of turns. Two solenoid equal number of turns. If number of turns is equal and have the length and radii in same ratio. Length ratio and radius ratio is same. 1:2. The ratio of the self-inductance will be. What is the ratio of self-inductance of two solenoid? Two solenoids of equal number of turns. First solenoid, yes, I want to take first solenoid, this is S1, I mean the number of turns is N1, and second solenoid, the number of turns is N2. Both N1 is equal to N2, the condition. The two solenoids equal number of turns. The length ratio and radii ratio is same, which means the length of the first solenoid L1, length of second solenoid is L2. So L1 by L2 is equal to the radius of solenoid. This is the area of cross section, radius of solenoid, and R1 by R2 is equal to 1/2. This is a question. And the length and radius of same ratio, 1:2. I want to calculate this. What is the self-inductance L1 and self-inductance L2? What is the inductance ratio L1 and L2? So you know where formula. What is the formula? L1 is equal to mu naught n square AL. This is a mu naught n square AL is the formula. First is self-induction mu naught N1 A1 L1. Second induction L2 is equal to same as I want to take in R medium. That's why mu naught N2 square A2 L2. A2 L2. But small n is the number of turns per unit volume. But if you have total number of turns, just convert to the formula. L1 is equal to mu naught N1 divided by L1 whole square A1 L1. Because of small caps n is equal to small n into L. Small n is equal to caps n divided by L. So caps n square is equal to small n is equal to caps n divided by L whole square. This I want to convert this formula in caps n. Same phenomena, L2 is equal to mu naught small n2 is equal to caps n2 divided by L2 whole square A2 L2. A2 L2. What is L1 is equal to mu naught? This is N1 square divided by L1 square into A1 into L1. Here L2 is equal to mu naught N2 square divided by L2 square into A2 L2. A2 L2. So L1 square cancel. So get L1 is equal to inductance is equal to mu naught N1 square into A1 divided by L1. Here L2 is equal to mu naught into N2 square, I mean L2 cancel. N2 square A2 divided by L2. A2 divided by L2. But this is the area of cross section, but we have to radii. So area is equal to pi r square. Convert this, another one. So L1 is equal to mu naught N1 square. A is equal to pi R1 square. Pi R1 square divided by L1. What is L2? Inductance L2 is equal to mu naught N2 square into pi R2 square divided by L2. Divided by L2. This is the final equations. We have to show all data. Just we had substitute this. We want to calculate this. L1 divided by L2 is equal to ratio mu naught N1 square into pi R1 square pi r1 square divided by L1 whole divided by mu naught n2 square into pi r2 square whole divided by L2. Now convenient, L1 divided by L2 is equal to mu naught n1 square into pi r1 square divided by L1 into L2 divided by mu naught n2 square into pi r2 square. Pi r2 square. So mu naught cancel. Pi cancel. Another one is solenoid of equal number of turns. If number of turns is same, so that's why n1 square equal to n2 square cancel. The remaining value L1 divided by L2 is equal to here R1 square divided by L1 into here L2 divided by R2 square. So simply write this L1 divided by L2 is equal to R1 divided by R2 whole square into L2 divided by L1. So R1 divided by R2 whole square into L2 divided by L1. L2 divided by L1. So L1 divided by L2 is equal to, what is R1 by R2 value? R1 by R2 is equal to 1 by 2. 1 by 2 whole square into L1 by L2 is equal to 1 by 2. But L2 divided by L1 is equal to 2 by 1. So 2 divided by 1. So L1 divided by L2 is equal to 1 by 4 into 2 divided by 1. Just cancel. 2. I mean 2 times 1, this is 2. L1 divided by L2 is equal to 1 divided by 2. Final answer L1 is L2 is equal to 1 is to 2. 1 is to 2. Inductance ratio is L1 is L2 equal to 1 is to 2. The next one, by a change of current from 5 to 10 ampere in a time period 0.1 second. Self-induced EMF is 10 volt. Induced EMF 10 volt. Current variable 5 to 10 ampere in time duration 0.1 second. The change in energy of the magnetic field of coil is, it's not a energy in a magnetic field. Change in energy. So change in energy means initial and final. The time duration 0.1 second and current variable 5 to 10 ampere. 5 to 10 amperes. First of all, I want to calculate this. What is data? Variable current I is equal to DI is equal to 5 to 10 ampere. 5 to 10 ampere, which means 10 minus 5 is equal to 5 ampere. 5 to 10 means a variable 10 minus 5. And time is dt is equal to 0.1 second. 0.1 second. Self-induced EMF is equal to 10 volt. Change in energy. What is the energy formula? You know, energy is equal to L I square divided by 2. L I square divided by 2. But you have the change in current value. I value as variables 5 to 10. But L is, there is no L value. So first of all, I want to measure L value. So E is equal to L into di divided by dt. You know well, L is equal to E divided by di divided by dt. So what is E value? E is equal to 10. 10 divided by di variable 10 minus 5. So 5 divided by time duration 0.1 second. dt is equal to 0.1 second. So which is equal to L is equal to 10 into 0.1 divided by 5. Cancel just 2, which is equal to 0.2 Henry. L value. L is equal to 0.2 Henry. But I want to calculate this change in energy value. So change in energy means U1 is equal to L I1 square divided by 2. L I1 square divided by 2. And U2 is equal to L I2 square divided by 2. So change in energy means a final, del U is equal to U2 minus U1 is equal to L I2 square divided by 2 minus L I1 square divided by 2. So which is equal to L divided by 2 I2 square minus I1 square. It's a common factor L by 2. That's why I want to take common factor L by 2 is equal to, what is L value? L is equal to 0.2 Henry. So 0.2 divided by 2 into, what is I2 value? 10. 10 square minus I1 is 5 square. So it is equal to, cancel this 0.1 into, this is 100 minus 25. So 10, 100 minus 25. So it is equal to 0.1 into 100 minus 25 is 75. So 75 into 0.1, so 7.5 joule is varied. This is variable, the energy. Change in the energy of magnetic field of coil is 7.5 joule. This is change in energy, U2 minus U1. It's not your energy stored in the coil. Change in energy with respect to time. U2 minus U1 is 7.5 joule. A coil of 200 turns carries a current of 4 ampere. If the magnetic flux through the coil is 6 into 10 power minus 5 Weber, find the magnetic energy stored in the medium. Magnetic energy stored in the medium. This data. A coil of turns, N is equal to 200 turns, carries a current I is equal to 4 ampere. The magnetic flux pi is equal to 6 into 10 power minus 5 Weber. Find the magnetic energy stored in the medium. You know well the magnetic energy stored in the medium U is equal to Li square divided by 2. Li square divided by 2. But there is no L value, so first of all measure N, inductance of the coil. What is L? L is equal to mu naught N square AL. But you have the Ni pi value. So what is formula? N pi is equal to Li, know well. So flux is directly proportional to, change in flux is directly proportional to current. So N pi is equal to Li. L is equal to N pi divided by I. N pi divided by I. So L is equal to, what is the N value? 200 into pi value 6 into 10 power minus 5 divided by I 4. Just cancel one time, this is 5 time. L is equal to 30. 300 into 10 power minus 5 Henry. So L is equal to 3 into 10 power 2 into 10 power minus 5. So we get 3 into 10 power minus 3 Henry, which is equal to 3 millihenry. 3 millihenry, L value. But I want to calculate, find the magnetic energy stored in the medium. Magnetic energy is stored in the medium. What is the formula? U is equal to Li square divided by 2. So U is equal to, what is L value? 3 millihenry. 3 into 10 power minus 3 into I square 4 square divided by 2. So U is equal to 3 into 10 power minus 3 into 16 divided by 2. Just cancel 8. So which is equal to 8 3s are 24 into 10 power minus 3 joule. So U is equal to 24 millijoule or 0.024 joule. 0.024 joule is the energy stored in the medium, given medium.